Hi, and welcome to a quick retrospective of the GE Minds Machines robotic demo. GE Minds and Machines is a conference to showcase IoT infrastructures. So for worldwide, we went ahead and bought an RV2A robotic arm by Mitsubishi. So what this meant to us is how can we showcase that we can connect to older hardware using a newer IoT infrastructure, and how do we harness the power of analytics to optimize that infrastructure? So this is day one. We have a robot, we have about 20 pounds worth of cabling, multiple controllers, and a whole mess of cards. The first thing that we ended up having to do was backwards engineer the entire robotics system. So once we had the robot moving, we were able to use the control software that comes with the robot through a TCP/IP connection and pull all of the instruction sets off the robot. What this allowed us to do was be able to backwards engineer how to control the robot as well as get data off of the sensors. We ran these movements for about 3 or 4 days, capturing all of the data onto an MQTT bus, where it was then, through a publish subscribe model, sent to multiple different endpoints. So let's talk about some of the architecture. Just a quick side note, I was vetoed on the naming of the robot, and so I have replaced its graphic with something a little bit more appropriate. So here we have the overall architectural diagram of the Predix Minds and Machines demo. The core of the infrastructure was an MQTT message hub. MQTT is a lightweight messaging system that allows us to cross-compile the client so that we can use the client on both microcontrollers as well as x86 platforms. So using the RT Toolbox software that is used to program the robot arm, we were able to take the TCP/IP connection from the controller and sniff the packets so that we would be able to get a list of all of the commands used to control the robot, as well as be able to take all of the data sent back from the robot and be able to push this up to the MQTT bus. Now with the data in MQTT, we were able to fulfill downstream dependencies. So the first one that we tackled was, how do we make sure that we don't lose any of this data? So what we did was build a store forward facility to write the data directly to a database and then monitor the uplink to the cloud to be able to pass that data when we had enough bandwidth. The next downstream dependency was the control and management of the robot itself. This usually comes in the form of an HMI, or a human-machine interface. Asynchrony wrote an HMI on top of a Raspberry Pi using some older visual technology, Java Swing, and connecting to both an MQTT interface as well as a RESTful interface for being able to do actual controls on the robot itself. We also skimmed the HMI with SVGs, allowing us to be able to directly manipulate each piece of the gauges as well as the robot framework that you see here. To be able to do the analytic visualizations, we used the Predix platform along with a Node.js server and a trained model trained by our data scientists to be able to do predictive failure analysis on the servos. For the near real-time analytics, we were using ElkStack, which is Elasticsearch, Logstash, and Kibana. What that gave us was the ability to monitor not just the sensors coming off of the robot itself, but we were also able to monitor disk usage, the amount of messages stored and pushed up to Predix, as well as CPU, system load for the virtual machines running on a Cisco ISR. The last function, and arguably the most fun function of the robot, was creating a visual tracking system. We used an off-the-shelf USB camera, and we were able to track the position of the robot arm gripper fingers in relation to objects, which we were able to find by both color and shape of the object. Once we found the color and shape of the object, we were able to sort it by color and shape. The next piece of this will be to incorporate a GPU solution to be able to run this at a much faster frame rate and be able to do machine learning against not only the shape and color, but be able to do actual object recognition and perform a task based off of that computation.